Assalamualaikum warahmatullahi ta'ala wabarakatuh. In this video, we like to present the application of linear algebra in electric circuit. Before we start, I would like to introduce my group mate. First one, Daniel Zafrin Shah bin Muhammad Arishah. Second one is Aminul Lafiq. Then Muhammad Akil. Last one is Muhammad Irham Shah. Now, let's begin with introduction. An essential tool for modifying electrical circuit is linear algebra. The use of matrices is regarded as a fundamental idea for electrician. The majority of computer programs are built using linear equations. To calculate the current flowing through the various branches of an electrical network, a system of linear equation is used. For example, sources of current push currents against various resistances as it travels through the network. For current to flow, each resistance must exert a certain amount of force. The current locations of the various electrical network branches are calculated using a system of linear equations. Next, we move on to purpose of study. Linear algebra is a prerequisite for almost every area of electrical engineering. Kirchhoff's voltage or current law allows for the simultaneous equational representation of any electrical circuits. For simple circuits, one permutation is sufficient to solve the simultaneous equation. Since the use of electricity at this time is crucial and necessary, we have decided to present the use of linear algebra in electrical circuits. The safety of the current that flow must be ensured by us, the resources users. Use node analysis for circuits with more complexity. Method used by us is Kirchhoff's law, Ohm's law, and Gauss-Jordan elimination.
Hi, I'm Afiq and I will explain about the methodology for this application. So exactly, the current loop of simple electric circuit can be converted into the system of linear algebra by using the current law stated by Gustav Kirchhoff. The law states that the amount of current entering, which is tossed into a parallel circuit, is equal to the amount of current exiting due to the of the same direction, which causes no loss of current. And so that we can get an equation to apply for this application of linear algebra. For your information, battery can be the source of the current loop or electric circuit that denotes as voltage or V symbol. And also resistance can be motor or light where the current flows out. And now let's take a look of the example question that have been given. The diagram shows a series circuit with a voltage and resistor value given. By using the Gauss-Jordan elimination method, find the value of the current flowing for each series of circuit in the picture. Give the answer to 3 decimal places. We can make the equation based on the diagram using the formula of Ri equal to V. That is, resistance times current flow is equal to volts.
Thank you, Aminul Afiq. Assalamualaikum and hi. My name is Daniel Zafrin Shah bin Muhammad Arishah. So I will continue our presentation. As we can see on the screen, to know the current flow on the circuit beside here, we should form the equation first. We found that 3 equation altogether, which is equation first is 9i1 plus 1i2 plus 3i3 equal to 7. And the second equation is 1i1 plus 12i2 minus 4i3 equal to negative 15. And last equation is 3i1 minus 4i2 plus 20i3 equal to 10. After that, to solve the problem, we use the Gauss-Jordan elimination method. In details, we transform the 3 equations into augmented matrix. We should make the matrix with reduced row echelon, RRE. After that, we multiply the first row with 1 over 9. And then, we minus the second row with first row. Next, we'll multiply the second row with 9 over 107 and minus the third row with 3 first row. After that, we minus the first row with 1 over 9 of the second row. We move to the next slides. Next, we plus the third row with 13 over 3 second row, and then we multiply the third row with 107 over 1864. Lastly, we minus the first row with 40 over 107 third row, and second row plus with 39 over 107 third row. Now we have done to make matrices to be identity matrix, and now we can know the value of current flow of the circuit. Now I will pass the microphone to my friend Irham. Thank you.
Thank you, Daniel Zafinsha. Now I will be discussing and talking about the results. Based on the methodology, the electric circuit can be solved by using linear algebra method. Linear algebra can also be useful when the network is more complicated and the number of the unknowns are large. Lastly, after we calculate and analyze the current flow, we found that the amount of current flow are correct and our circuit is safe and ready to be used, and the amount of current is enough to light up the bulb. The result of all three systems is as follows. I1 is 0.88 amps, I2 is negative 1.29 amps, and I3 is 0.11 amps. To conclude, in electrical engineering, matrix can be used to represent and analyze electrical circuits. The behavior of electrical components such as resistors, capacitors, and inductors can be described using systems of linear equations. By representing these equations in matrix form, techniques like matrix inversion, Gauss-Jordan elimination method, and matrix multiplication can be applied to solve the circuit and determine important parameters like voltage, current, and power distribution. And that is all from our group. Thank you for lending your time to watching this video. We hope that this group project can enlighten you about one of the applications of linear algebra in daily lives. Thank you. See you in the next video.